So the next one is periodic table and periodic properties of elements. So for biochemistry, you have to take notes. You have to learn how to use the periodic table very very well to help you in your daily studies and exams as well. And the periodic table, it was proposed by Mendeleev. Yeah, Mendeleev brought about the periodic table. Periodic table, it consists of groups and what? Period. The groups are the vertically arrangements of the element, and the periods are the horizontal arrangement of what? The element. So we have 18 groups, um including the transition metals, and there are 8 groups when the transition metals are what? Excluded. So for the periodic table, there are so many informations you can get about it. So for an element to be in maybe group 1, group 2 or group 3, its last electron has to be on a specific block. So for the groups we have the S block, we have the P block, we have the D block, and what? The F block. So we have SPDF, SPDF. So in a question they can give you which block is lithium, which block is lithium. Normally the S block is found the leftmost part, right? On your right hand side will be the P, the middle is the D block, and the beneath the D block is what? The F block. So to for an element to be in a specific block, its last or valence electron has to be on that orbital. So if for lithium, so you can see the example there. For lithium, its last electron is on the S orbital. Yes, so that's how it is for both the groups and the blocks as well. Yes. So the groups also they help us to determine the physical and chemical properties of the elements. So if I have the same element in a specific group, I know that they have similar what features. Examples of the um groups are, we have the alkali metals, we have halogens and chalcogens and so forth. Periods are the horizontal arrangement of the elements, and we have period 1, period 2 up to period 6. Yeah, up to period 6. So for periodic properties, we are coming to look at the physical and chemical properties of atoms which reoccur on the periodic table. So we have atomic size or radius, ionization energy, electron affinity, electronegativity. So before we start with this one, we will talk about valence electron. The valence electron, they are the outermost electrons involved in bond formation. So valence electrons, they are the last electrons in an orbital, and these are the electrons. So in an exam, when you are being asked which electrons are being or which electrons take part in chemical reaction, that's the valence electrons. So for example, for an ion to be formed, its valence electron has to lose or gain what? An electron. We have core electron. Core electrons are the innermost electrons within the atom. We have effective nuclear charge and screening effects. The effective nuclear charge is the net attraction of proton in the nucleus for the valence electron. Screening effect is, it is the decreased attraction of proton for valence electrons by the core electron. So the screening effect, you can see that the screening effect is the shells. For the screening effect, it reduces the amount of energy or the attractive force that the nucleus will use to pull protons or electrons to itself. So the screening effect, you can imagine that the shells which decrease the attraction of protons to what? The valence electrons. The first one we start with is the atomic size or atomic radius. For atomic radius, it is the half the distance between two bonded nuclei in a molecule. So the size of an atom is dependent on how strongly the protons is or the protons in the nucleus attract the valence electron. So for the various elements, the atomic radius will help us to know how small or big an what electron or sorry an atom is. This can be determined by how strongly protons in the nucleus attract what the valence electron. So you can see that for all the elements, we have when you have few electrons and more protons, your the atomic sizes what will be smaller. But when you have more electrons and few protons, you see that the size will be what? Bigger. So that one will come into the cationic radius and what? Anionic radius. And take note of this one. Across the period, screening effects due to electrons in the same shell almost remain constant. So when you move across the period, you see that the shells they are very constant. Screening effect is very constant. So if you draw the electronic configuration, you see that across the period they will have the same number of shells. Yes, but the effective nuclear charge increases as the atomic number what increases by one. So effective nuclear charge is how the nucleus pulls the valence electrons to itself. So the more the protons, the higher the effective nuclear charge for it to pull valence electrons to itself. The greater the attraction for valence electron, the smaller the size of the atom. So when the effective nuclear charge is high, the size of the atom will be smaller because it can pull most of the electrons to itself, making it smaller in size. But when the effective nuclear charge is very low or is weak, the size becomes what? Bigger. So across the period, atomic sizes atomic sizes dey increase across the period because there will be increase in effective nuclear charge with a constant shielding effect. But down the group, effective nuclear charge also increases and there is an increase of the shielding effect. So down the group, effective nuclear the atomic radius decreases down the group. Decreases means that from large to what? Low. Across the period, it increases so from low to what? High. So for cationic radius smaller than parent atom. So all cations are smaller than parent atoms. This is because the ions, cations, they lose their electrons. So as a result of this, there will be more protons in the nucleus to pull the electrons to itself, making it smaller. So all cations are very small because they lose electrons. So when the for you to lose electrons, making protons very much, it increases the effective nuclear charge. So the nucleus can pull the electrons to itself. So cations are very small compared to their parent atom. But anions they are very large because for anions they gain more electrons. So making the protons less. So the nucleus will not have effective nuclear charge to what pull electrons to what itself. That's it. So for ionization energy is the energy required to remove the most loosely bounded electrons from a gaseous atom. So ionization energy is just the minimum amount of energy you have to get to remove an electron from a gaseous atom, and its determinant are atomic radius. So you have to consider the atomic radius, theory effect, stability of the electronic configuration, the penetrative effects of the ionization or of the atom before you can um know that okay, this element has a higher or lower ionization energy. So ionization energy dey decreases down the group because as you go down the group, atomic radius will increase, and screening effect also, it decreases the penetrative effect as well. But across the period, ionization energy what decreases, sorry, increases. So down the group, ionization energy decreases. Across the period, ionization energy what So the reason why we are saying that down the group ionization energy increases is that for ionization energy is that the